And there's a couple different ways that you can be asked to find a z-score. One of the ways that you can be asked is to find a percentile. And remember, with percentiles, we always start from the left for percentiles. On our curve, the bottom is the left of the curve and the top is another phrase for the right of the curve. So let's go ahead and do an example. I'm asked to find the bottom 75% of a curve. This is the same thing as being asked to find the top 25% of a curve. So let's go ahead and look at our picture. So we've got our bell-shaped curve. I know there's 50% on each side of the curve, so if I'm trying to find the bottom 75%, then I'm going to go 50% to the middle and then a little bit further past that. So my z-score is somewhere to the right of 0. I don't necessarily know if it's lined up right, but I at least know it's going to be a positive number. I've got 75% on the left and 25% on the right. So the bottom 75% shares a wall with the top 25%. And that 25% is from the complement, right? 1 minus 75 gives me the 25%. Okay, so now I'm going to go into the table looking for 0.75. So I'm looking for 0.75, and at first I might just start with my table and say, too small, too small, too small, too small. Wait a minute, all these are too small. Well, the thing to realize with these numbers is, remember, we said 0.75 was past the middle mark, and this is just the left half of the table, and I know I'm going to have a positive z-score, so I shouldn't have even been looking on this table. So now I come over here and I seriously bounce around. This is too small, this number is too big, too small, and then wait, I'm getting closer. Okay, here we go. Here's the combination I want. 0.74 is too small and 75 with other stuff is too big. So the row I want to work with is 0.06 and the columns I want to look at are 0.07 and 0.08. Okay, so in the table we found that in row 0.6 under column 07 there was the number 7486, which was too small. And under column 08, there was 7514, which was too big. The number 75 that we were looking for would have been in between those two numbers. And remember, if you saw it as a 4-digit number, it'd be 7500. So we know that our number would be in between those, so we need to find their distance. One is 0.0014 away, and the other number is 0.0017 away. So 14 feet away from something is closer than 17 feet. So we're going to get our z-score from the 7486 value to use the 0.6 and 0.07 so that we can put those as an answer of 0.067. Now be careful when you get 0.67, stop. Do not move the decimal and make that answer into a percentage. The answer is a z-score. It's not a probability question, so don't move the decimal. And then that same question that we just did, how would we have asked the question in percentile notion? So instead of saying find the bottom 75%, the question could have read find P75. Remember, P stands for percentile versus Q for quartile, and a subscript on the right tells you which percentile. So we could have actually said Q3, right? Okay, so I said there's a couple different ways. One way is to ask as a percentile. The other way is Z alpha, where alpha is a subscript. That's the Greek lowercase letter a. And as a subscript, it's telling you to find area to the right. Big deal. Because P75 was area to the left, really? But Z alpha is going to be area to the right. And you'll see that in a second in this next question. If I was asked to find the top 1%, this is the same thing as being asked to find the 99th percentile, P99, the bottom 99%, or Z01, that new terminology. Because remember, the top 1% is area to the right, and Z uses area to the right. So there's lots of ways to ask the same question, and in all of these cases, I'm given the number that's in the middle of the table. I have to find a z-score. So if I drew my curve and I wanted to find the top 1%, which is a decimal is 0.01, or, 0.0100 to see it as a 4-digit number. Now, keep in mind, the table finds area to the left, and we wanted to look, that means we're gonna have to look up the complement to find area to the right. So I'm gonna have to take 1 minus 0.01 to get 0.99. That's the number I'm gonna look for in the middle of the table. So let's go to the table. So now I'm looking for 0.99 in the table, and this time I'm being wise, and I knew that for the top 1%, I'm gonna have a positive z-score, so I'm gonna start with this table only. And like I told you, I jump all around. That number's too small, that's still too small. Wait, 9911 is too big, so I've got to be getting closer. Too big, too big, too big, too big, too small. Wait, that's it. I'm in the right pattern, so I need to back up, because I want one number that's too small and one number that's too big. So I want to take the numbers from row 2.3 and decide who is closer from columns 02 and 03. Okay, so from the table, I found that in row 2.3, under column 02, I had 98, which was smaller than I wanted, right next to the number 9901, which was bigger than the number I wanted. 99 would have been right in between them. So I see how far away they are. The first number is 102, 102 feet away. The next number is just 1 foot away, 1 unit. So that's the closer number, and that's what I'm going to be using to get my answer, which my answer box isn't here, but it's on yours.